This lesson is on solving inequalities using addition and subtraction. These are similar to your one-step equations, but with inequalities. So we have our addition property of inequality and our subtraction property of inequality, which are exactly like your addition property of equality, except it doesn't have an equal sign. It has an inequality sign, which is that greater than or less than sign. Now your addition property of inequality says if you have A is greater than B, then A plus C is greater than B plus C. And all that's saying is as long as you add the same number to both sides, this is going to stay as a greater than sign. Same thing with your subtraction property of inequality. If you subtract the same number from both sides, then you're going to have something that's still true. You're going to have A minus B, or A minus C is less than B minus C. Let's see how that applies to numbers and equations. So, solving an inequality and graph it, and then you can check your solution. I'll show you how to check these answers. If you have x minus 14 is greater than negative 12, I want you to learn those names. So this is a greater than. In order to get the x by itself, what you're going to do is add 14 to both sides. Since it's minus 14 here, you add 14 to both sides, and you get x is greater than 2. Those cancel out. Negative 12 plus 14 gives you a positive 2. Since your letter's on the left, it makes it easier to graph it. We're going to go down here, 0, 1, 2, so I need to get at least to here. Because we talked about this, you have a greater than symbol or less than symbol, you have an open circle. And if you have a greater than equal to or less than equal to, then it's going to be a closed circle. So this right here, because it's greater than, it's going to be an open circle at the number 2. And then it's all the numbers that are greater than, bigger than 2, which would be everything in this direction. So it's similar to graphing from before, except you have a step you have to do before you can graph it. Now I also said you could check your answers, and the way you check your answers is you pick a number that you graphed, like 3 or 4 or 5 or a million, it doesn't matter. You can pick any of those numbers and you plug it back into this original equation to make sure it works. So I'm going to pick the number 4 right here. 4. Is 4 minus 14 greater than negative 12? So 4 minus 14. 4 minus 14 is negative 10. And is negative 10 greater than negative 12? And it is. And so that tells us that's a correct answer. If you would have picked a number down here, you'll see that it's wrong. So if you're double checking to make sure that you shaded it the correct direction, that's something you can do. I'm going to pick the number 0 because it's something that should not work. So 0 minus 14 is greater than negative 12. 0 minus 14 is negative 14. And is negative 14 greater than negative 12? No. So this side should not be shaded. So that's a way to make sure that you shade it in the correct direction. So look at this next one. We have n minus 7 is less than or equal to negative 3. So minus 7, we're going to add 7 to both sides. So this is our addition property of inequality. You're adding the same number to both sides of the inequality. Gives you n is less than or equal to 4. So I need to pick 0, 1, 2, 3, 4. 4 is right here. We have a circle at 4. Now that circle is a closed circle, colored in circle because it's equal to. So we colored in saying, hey, that one's supposed to work too. And then we have all the numbers that are less than positive 4. So we're going to shade all the one this direction, and the arrow. You've got to color in the arrow because it does continue to go on forever. It doesn't just stop there. Next, we're going to start working with our subtraction property of inequality. Subtraction property of inequality says that if you subtract the same number from both sides of the inequality, it is still true. So 20 minus 15 is 5 is greater than x. Now because my letter's on the right, I'm going to switch it around. Put the letter on the left, and as I switch sides with those numbers and letters, I also have to switch that sign, so it's still pointing at the x. It's still got to point at the x. So we have a circle at 5. It is an open circle, not colored in. And we want all the numbers smaller than 5, so that's all the numbers this direction, to the left. Number 4 here, we have y plus 8 is less than negative 4. So we're going to subtract 8 from both sides. Y is less than negative 12 now. Now this isn't going to fit on my graph, so I might have to count by something different. Let's go choose. Negative 2, negative 4, negative 6, negative 8, negative 10. Still not going to fit, so we're going to continue this line on. Negative 12, negative 14, that's long enough there. Okay, so we need circle at 12. It's going to be an open circle, and we're going to shade everything smaller than negative 12, which is this direction here to the left. We have all the numbers less than negative 12. Now I'd like you, if you're watching this video, to pause it and try these 3. So go ahead and pause it, try these 3, and then come back and check it. Okay, to go through these problems, what we're going to do is add 3 to both sides. We get x is less than 11. 11 there. And x is less than 11. If you were to graph this, you would have 11 somewhere over here. So as you get on that number line, you have 0, you have 11 clear over here. It would be an open circle at 11, and you would be shading everything to the left. This here we have plus 12, so I'm going to subtract 12 from both sides. 7 minus 12, we get negative 5, is greater than or equal to x. Hopefully you remember them. We need our letter on the left. So we're going to switch those sides, and when we switch those sides, we switch the sign. And 1, 2, 3, 4, and 5. This would be a closed circle at negative 5. And all the numbers less than would be this direction here to the left. And the last one you had to work on was you subtract 5 from both sides. You get y is less than negative 14. Again, you would have an open circle at negative 14, and we would be shading everything to the left. So we have 2 word problems today. Our first one says a hard drive on your computer has the capacity of 120 gigabytes. You have used 85 gigabytes. You want to save some home videos on your hard drive. What are the possible sizes of the home video collection you can save? So I'm going to use X in my problem, and the question was, what are the possible sizes of the home video collections you can save? We're going to call that our sizes. So the total we have is 120. When you get that total, when we're doing equal signs, the total we would always put here off by itself. And we're going to do the same thing here, except it's not going to be an equal sign. It's going to be an inequality. We're going to change that over to an inequality here in just a second. And the other things you put on this side were how you got to that 120. So right now we've used 85. In addition to that, we have some space available, and we want to see how much space we have available. So the space we've used plus the space we have available equals the total number of gigabytes that we have on the hard drive. Now, do we have to use them all? Well, the answer is no. Right here, we've already used 85. That means we haven't used them all. So that's why it's not an equal sign. It's not an equal sign because you don't have to use them all the time, and hopefully you don't. So you got to figure out, can I use more than 120? If your hard drive has 120, can you use more than 120? No, you can't use more than. Could you use less than 120? Absolutely. Right here, we've already used 85, so that means I haven't used them all yet. Could I use all 120? And yeah, you could. So it is equal to also. So here's your inequality. Now let's solve it to find out what sizes we have left. We would subtract 85 from both sides. And we have x is less than or equal to, that equal to sign there, 35. So now what I want you to do with that is to explain your answer. Because we have inequalities, it's not just the number 35 anymore. It's everything that's less than 35. But then you have to think about it. Is there some other restrictions? It has to be a positive number, doesn't it? So what I would say is you could use, the sizes you could use, the sizes you have left, is between 0 and 35. Or you can use up to 35 gigabytes. Something along these lines. I need a sentence. You can use a phrase like this, up to 35 gigabytes. At most, 35 gigabytes can be used. But it needs to be in a sentence form. So it's got to start with a capital letter, end with a period, have a full sentence in between there. Next one says the club has a goal of selling at least 25 plants for a fundraiser. Club members sell 8 plants on Wednesday, 9 plants on Thursday. What are the possible number of plants the club can sell on Friday to meet their goal? Okay, so the total we want to sell is 25. That's our total. That goes over here. How do we get to that 25? Well, we've done some selling already. We've sold 8, we sold 9, and we have some more to sell. So that X is how many we need to sell. So I'm going to call that Friday sales. And define that variable. Now, we don't want to just put a 17 here. You want to list it exactly how it is in the problem, and you can solve it after that, but list it exactly as it is in the problem. Is it okay to sell more than 25? Well, yeah, if we raise more, then that would be good. Could we sell less than 25? Well, if we did, we wouldn't meet our goal, which is what we want. So what if we sold exactly 25? Would that be okay? And the answer here would be yes also. So we want a greater than or equal to sign. Now we can go ahead and add those together. Do your subtraction property of inequality. Subtract the same number from both sides of the equation. So that should be a 7 there. So 25 minus 17, you get 8. So what does that mean? That means the club must sell 8 or more plants. Make sure you explain what that answer means.